Okay, Chapter 28 for SMAW. Chapter 28, we've been using it for a lot of our electrodes for your GMAW class. We're going to be using it for probably every one of your welding processes. The whole chapter is about electrodes and filler metals for different welding processes. For stick welding, we are going to focus on the rods that we're going to be using out in the shop, which are going to primarily be a 60-10 and a 70-18. These are both your electrode and filler metal. A short review from GMAW. What is an electrode? Electrode basically carries current. It can be used as a filler. Sometimes it can be used just to carry current. For example, like in TIG welding, your electrode in your TIG welding process is just to carry current. You're not going to be burning your tungsten electrode up. You're going to be actually manually putting a filler material in. Just the opposite for SMAW. Your electrode is going to be also your filler material. So keep that in mind, but the primary function of every electrode is to carry current. Now, the two rods that we're going to focus on are basically a 60-10 and a 70-18. You're going to be using primarily your 70-18 electrode. We are going to do some exercises out in the lab where you're going to do a 60-10 rut, a 70-18 overlay. So what do those numbers actually mean? So when we say 70-18, what do these numbers mean? Typically your first 2 or 3 numbers, I say 2 or 3, primarily it's going to be 2. This means that we have 70 thousandths tensile strength. What is tensile strength? Tensile strength is the ability to actually pull that material, how much force it takes to pull it apart. So when they actually do these tests to actually test the material, it takes 70 thousandths pounds per square inch to rip that piece apart. So the first 2 digits, 2 or 3 digits, I say 2 or 3 because another example would be like 118. That means that this first 3 digits, you have 100 thousandths tensile strength. Primarily, you probably won't be welding to something with that high tensile strength. We're going to be using 70-18 out in our welding lab. So 70, actually you're at 70 thousandths tensile strength. The second digit means the positions that it can be welded in. 1 represents all. 2 represents flat and horizontal. And you can actually have a 4 also, which is flat, horizontal. Vertical down. And so on. So as you can see, the 1 right here is telling me that we can weld this electrode in all positions. All positions. The last digit tells me the composition of the flux. So for example, this means it's a low hydrogen electrode. How do I know? Because it ends in a number 8. If it ends in a 5, 6, or 8, it's always going to be a low hydrogen electrode. So for example, a 70-16 is a low hydrogen. A 70-15 would be a low hydrogen rod also. So 70-18, first 2 digits is you multiply it by 10 thousandths. So 70 times 10 thousandths is 70 thousandths tensile strength. The next digit right here, the second to last, is telling me what positions I can weld with that rod. The 8 is telling me the composition of the flux. So this is a low hydrogen electrode. Like I said, if it ended in 5, 6, or 8, basically they're all the same. There's a little bit of difference in there. So these are the primary things of your electrode. It's going to tell you. Now electrodes, they can come in multiple different diameters. Typically we are using an 1/8 inch electrode. What does that mean? That means that center core is 1/8 inch diameter. Right here. That center core is an 1/8 inch. 1/8 inch is pretty much the most common. I mean, you can go 1/16, 5/32, but that is telling me that center core of that electrode is an 1/8 inch. We use all 1/8 inch here. There's probably the most common. The main thing is understanding these numbers. Now, 7018, since it's a low hydrogen electrode, what current can we use? All low hydrogen electrodes can be used with AC and DC positive. We talked about currents in some of the other chapters. So this electrode is designed to weld an AC or DC electrode positive current. It has a 70 thousandths tensile strength. It can be welded in all positions, and it is a low hydrogen electrode. When you think of low hydrogen, think of water. H2O has a high hydrogen content. 2 molecules of hydrogen, 1 of oxygen. So these are basically considered low moisture rods. These are also kept in an oven primarily. Once you open the container, they keep them in an oven at about 150 degrees. They're stored at 150 degrees, and they're stored at 150 degrees for a reason. And so it keeps the moisture contaminating the rod. So for example, if I had my rod and I had it sitting right here on that ledge for days on end, the moisture in the air actually soaks into that rod. So we keep the low hydrogen electrodes, we keep them in an oven. There's one out in the welding lab. The main reason for that function is to keep the moisture out of the rod. We'll go through 6010 also. This is primarily it for 7018. Keep in mind it's a tensile strength, weld position, and what type of flux coating it actually has. And once you kind of get this pattern down, it follows suit with all the other electrodes. So for example, we're going to go into a 6010 electrode. You're going to be using that in the lab also. 6010. What does that mean? These first 2 digits right here tell me that it has 60 thousandths tensile strength. One tells me it can be welded in all positions. 0 tells me it's a high cellulose rod. We talked about some of the different flux coatings of some of the other chapters. So 6010 has a 60 thousandths tensile strength, can be welded in all positions, and it's a high cellulose rod. Now you look at the flux coating on a 6010 compared to a 7018, there's not near as much flux. So for example, here's a 7018 overall diameter. Here's a 6010. So you can see the amount of flux compared to a 60. We still have an 1/8 inch center core, so it's still an 1/8 inch electrode, but you can see the 6010 has a lot more flux coating on it compared to a 6010. High cellulose rods are basically 0 and 1. They end in a 0 and a 1. So a 6011 would also be considered a high cellulose rod. Like I said, once you start getting this format down, everything will follow suit. It doesn't matter what type of electrode you actually grab. So what types of currents do we weld with the 6010? 6010 is designated, since it's a high cellulose rod, it's designated for DC electrode positive. You can weld it in other currents, but it's not going to weld near as good. It's designated basic for DC electrode positive. Some of the other common rods that are out in industry too are like a 6013. Follows suit. Same thing here, 60 thousandths. Tensile strength, all positions. This is telling me the composition of the flux. Now this actually 6013, it can be welded in all currents, which means AC, DC electrode positive, and DC electrode negative. Now, a lot of your test questions too are going to come off these PowerPoints, so make sure you're taking notes. 6013, it's kind of an all-purpose rod. It's used all over. Works good in just about all positions. So, main thing is understanding tensile strength, weld position, and what type of flux coating. Let's go over a different rod. Let's say like a 7028. This tells me I have 70 thousandths tensile strength. This tells me it's designated for flat and horizontal welding positions. This here tells me it's a low hydrogen electrode. So as you start getting this format down, it should follow suit. Like I said, we're going to be using Chapter 28 for other electrodes and filler metals and things like that. For SMAW, the main thing is to focus on are your 6010 and 7018 electrodes. That's what we're going to be using here. Understand what they mean. So 6010 and 7018 are the two rods that we're going to primarily focus on, because that's what they primarily use for the pipe fitter union and things like that. 6010, like I said, it's high cellulose. Run a DC electrode positive. 60 thousandths tensile strength, welded all positions, high cellulose rod, DC electrode positive for your current. 7018's got a 70 thousandths tensile strength, weld all positions, low hydrogen rod. Primarily you're going to weld it in DC electrode positive, and it's also stored at 150 degrees Fahrenheit. Now 6010s, they're typically not stored in a rod oven, typically because what actually happens is that they get too dry and the flux actually starts to crack off. So keep that in mind too. So for this unit, that's all I really want you to know. Understand what these numbers mean, how to apply it, and how to set up your welder accordingly. All right, thank you.